Welcome back to Creative Ideas plus AI. I'm Lucky. This week, we taught an AI to listen to emergency radio traffic and understand what people are saying. Real calls, real noise, real jargon, and we did the whole thing from a den at home. No data center, no cloud servers, no team of engineers, just two of us, an idea, and tools that didn't exist a year ago. Let me tell you how it went. So here's the problem. Emergency radio is arguably the hardest audio for AI to transcribe. You've got background noise, static, people talking over each other, 10 codes, phonetic alphabet, street addresses rattled off at speed, unit numbers, and dispatchers who've been doing this for 20 years and talk in a shorthand that's basically its own language. Every off-the-shelf speech model we tested choked on it. Google, OpenAI, Whisper, you name it, they all struggled. Not because they're bad models, they're incredible at regular speech. But radio traffic isn't regular speech, it's a completely different domain. So we decided to build our own. First problem, you can't train an AI without training data. And not just any data, you need ground truth. That means thousands of audio clips, each paired with an accurate transcript of exactly what was said. Hiring humans to transcribe emergency radio, that's expensive, slow, and honestly, humans get it wrong too. So we built a pipeline. We take each audio clip and run it through a frontier AI model. Not once, multiple times, at different settings. Then we compare the results. If the model agrees with itself across multiple passes, we score that transcript as high confidence. Think of it like having multiple expert transcriptionists independently review the same clip, and only keeping the ones where everyone agrees. That gives us a factory for generating reliable training data at scale. Thousands of clips, automatically. Here's where it gets interesting. We took our training data, loaded up a 1 billion parameter speech model, and fine-tuned it. Standard approach, nothing fancy, trained it overnight. The loss curves looked perfect. Validation loss went to 0. We were thrilled. Then we tested it on new audio. Silence. The model output absolutely nothing. Empty. On every single clip. What happened? The model had memorized the training data perfectly, but learned nothing generalizable. In machine learning, this is called catastrophic overfitting. It's like a student who memorizes every answer to last year's test but can't solve a single new problem. Our AI had a photographic memory and zero comprehension. Classic mistake. And honestly, that failure taught us more than a success would have. So we went back to the drawing board. A speech model has two main parts. Think of it like ears and a brain. The ears, the encoder, that's the part that processes raw audio into patterns. The brain, the decoder, that's the part that turns those patterns into words. Our first attempt retrained everything, all 1 billion parameters, on a relatively small dataset. Too many knobs to turn, not enough examples. Recipe for memorization. Second attempt, we froze the ears completely. The model already knows how to hear. It was pre-trained on massive amounts of audio data. We just needed to teach the brain to understand a new language, the language of emergency radio. So we locked 600 million parameters in place and only trained the 400 million in the decoder, added regularization, weight decay, gradient clipping, all the safety rails, kicked off the training run, and let it cook. Now here's the other piece. This can't run in the cloud. When a dispatcher is sending officers to an active scene, you can't have a 2-second round trip to some server farm. Latency kills. And in public safety, there are strict rules about where data can live. So we designed a local appliance, a small box that sits right in the facility. It runs the AI model locally. Audio goes in, transcriptions come out. No internet required for inference. Data never leaves the building. We looked at different hardware options, did the math on memory bandwidth, concurrent streams, and cost, and mapped out 3 tiers, from a small setup that handles a handful of channels to a beast that can process 30 or more simultaneous radio streams in real time. All of that analysis, the hardware comparison, the concurrency modeling, we did it in an afternoon. From a home office. One of the biggest lessons this week, one agency's data isn't enough. If you only train on radio traffic from one facility, the model learns that facility's quirks, one dispatcher's accent, one radio system's audio signature, one region's street names. That's not learning radio. That's memorizing one radio station. So we started pulling data from multiple agencies, different states, different radio systems, different audio characteristics. Analog systems with static and bleed, digital IP systems with clean, crisp audio, short clips, long calls, different dispatchers, different protocols. Right now we're processing 5,000 clips from a second agency while the model trains. That's the beauty of the pipeline we built. It scales, more data in, better model out. And here's the part that still kind of blows my mind. We did all of this from a den, at home. No data center, no bank of cloud servers, no team of 14 engineers, 2 people, a desktop GPU box, an AI coding assistant, and determination. We built a training data pipeline, trained a custom speech model, designed an edge computing appliance, ran hardware analysis on 4 different platforms, built a benchmarking system with a full dashboard, and started processing data from multiple agencies in 1 week. Back in episode 3, we talked about the supersonic tsunami, how technology is accelerating so fast that the tools available today would have seemed impossible 2 years ago. This week, we lived it. The barriers to building real AI products, the ones that used to require millions in funding and a team of specialized engineers, those barriers are falling. Fast. If you have domain expertise and the willingness to learn, you can build things right now that would have been a startup pitch deck a year ago. So let me put this in perspective, because I think this is the part that really matters. The person behind this project is not an engineer, not a data scientist, not a machine learning researcher. He's a sales guy. He runs a company. He's been in the industry for 25 years, and his technical background is knowing the product and knowing the customer. He doesn't write code. And yet, in 1 week, working from his den at home, he built a custom speech recognition pipeline, fine-tuned a billion-parameter AI model, designed edge computing hardware for 3 different deployment tiers, ran concurrency analysis across 4 platforms, and started processing thousands of audio clips from multiple agencies. How? Because AI did the engineering. He brought the domain expertise, the 25 years of knowing what the problem actually is. He brought the data. He brought the vision. And the AI handled the code, the architecture, the debugging, the math. This is the part that would not have been possible a year ago. 12 months ago, the tools to do this either didn't exist or cost a fortune. You needed a team, you needed funding, you needed months. Today, if you have deep knowledge of your industry and the willingness to sit down and build, you can create things that used to be reserved for companies with 50 engineers and 10 million in the bank. That's not hype. We just did it. The playing field hasn't just leveled, it's been flipped. That's the week. The model is still training, the data pipeline is still running. Every week, it gets better. If you're a founder, a domain expert, someone who knows your industry cold but thought AI products were out of reach, I'm telling you, the tools are here. Right now. Go build something. If you want to follow this journey, hit subscribe, drop a comment, tell me what industry you're in and what you'd build if you could. I'm Lucky. This has been Creative Ideas plus AI, Episode 6. See you next week.